Okay, so for the next part, we're going to be actually dealing with logarithms and specifically talking about the definition and some of those properties of logs. So before I actually start any actual specific questions, real quick, I thought I would just write down some of the things that we know. The definition of log says the log base a of b is c. That means that a raised to the c power is b. And you might remember that we talked about how the fact that when you look at these, the answer to a log question is, hey, what's that exponent? Meaning, if we said the log base 5 of 25 was the question, then we know that that answer has to be 2 because 5 squared is 25. Or if we said the log base 8 of 2, 8 raised to what power is 2? That would be 1/3 because it's the cube root, or maybe one more, the log base 7 of 1/49. That would be -2 because 7 to the second power would be 49, and a negative exponent is a reciprocal. Now, we had a couple of little special rules. This is all based on the definition of log, but we had some special rules that it doesn't matter what base your logarithm is. If you ever have a problem where you have a product involved in your story, like the log base a of x times y, then that would be the log base a of x plus the log base a of y. Now, without make the video too long, we know that the log base a of x divided by y means instead of adding the two pieces separately, we're going to go ahead and subtract them. And our final property that we're going to use in this is if you have the log base a of x raised to the y, that allows us to bring that in front, which is what you saw when I went through the video about solving logarithms a few moments ago. So anyway, without any further ado, let's take a look at a couple of problems. So, hey, the log base 3 of 1 over 81, well, you know that 3 to the 4th is 81, I hope, or 3, you could figure it out. 3 times 3 times 3 times 3 is 81. And of course, it was upside down, so it's going to be -4. Now, the second problem, I think that fifth root is a little scary, but I'm going to go ahead and use the rule that I mentioned right here, that you can take exponents and bring them in front. So I had brought the 1/5 to the front, and then I just looked at this, and all of a sudden that's not so hard because 4 to the second power is 16. So if this is 1/5 times 2, this answer is 2, I get 2/5. And last but not least, similarly, this 3 could come in front, and I know that 7 to the second power is 49, so this answer right here is 2, and 3 times 2 is 6. Now, I will note that on a problem like this, what we could do is we could double check something according to the definition of logarithm. When I did this problem right here, I'm saying this answer is 2/5. So in other words, I'm saying 4 raised to the 2/5 power, because that's the answer. I get this weird decimal. I'm saying 4 raised to the 2/5 power should be the 5th root of 16, or in other words, 16 to the 1/5. And if I've done this problem right, those two answers should in fact be the same, which they are. Okay, moving to number 7. Number 7 is one of those problems where we ask to use the property of logarithms to expand. So notice this is the natural log of e cubed right here, plus 3/7 the natural log of y minus 2ln(p). Now, I just kind of went very quickly through that because I'm kind of done with it. There's not much to say. I subtracted because it's division, and I used the property that allowed exponents to come in front. The only thing that I didn't specifically mention, remember, is since the base of a logarithm is base e, the natural log of e cubed is just 3. In the same way, the natural log of e to the 4th would just be 4. The natural log of e to the x would be x. Okay, now in the next little piece of this is a little bit of a blast from the past that we went over, where we decided to make the natural log of 2a. We made the natural log of 3b and the natural log of 5c, just playing with some prime numbers to make it workable. So when I took the number 150 or the number 10 over 27, I decided to break those into pieces that I could digest. And I noticed that 150 is 2 times 75. but 75 is 3 times 25, which is 5 squared. So using the properties of logarithms, that times and that times become those addition signs. And remember, that rule says I could bring the 2 in front. But notice that I can only bring the 2 in front of that piece. Now, if it helps, I could have written it this way first, and then brought that 2 in front secondarily, just to be a little bit more clear. And we already said the natural log of 2 is A, natural log of 3 was B, and there's 2 of those C's. I'm done. Now, number 9, of course, has a little division. 10 is 2 times 5. 27 is 3 to the third, so I'm going to do the natural log of 2 times 5, and I'm going to subtract, because that's what division tells me to do, and I have A plus C minus 3B. Now, again, try not to be too long about these problems. I can double check some things by storing the natural log of 2 as A. I'm going to store, I could take the natural log of 3 and store that as B, and the natural log of 5 and store that as C. Now again, this does not have to be done, but it is kind of helpful to try. So in that problem, I said the natural log of 150 is some strange number, okay? That's what my calculator says. It says e raised to the 5.01 power is 150. Well, up here, I have claimed that my answer is A plus B plus 2C. So let's see, A plus B plus 2C. Hopefully I get 5.0106. It tells me that I did that problem right. My A, B, and C lined up. In this problem, I said it was A plus C minus 2B. A plus C minus 2B. That's minus 3B, I should say. So a strange little decimal, negative 0.99. So let's see, if I took the natural log of 10 over 27, hopefully I'm going to get negative 0.993, and I did. So kind of cool. Now, the last rule that I did not specifically mention when I went through this, because these are technically called the properties, and there's one that is a special rule, and that says that if you have a base that you do not like I don't like base A, I would like to do base C instead, we can rewrite the problem as log base C top and bottom. I can put my original question in with this log base C of B, and then do the log base C of A. Now, that's going to be required in this next problem because I had you do the log base 5 of 15. And I am looking at this as kind of strange. I don't know why I did this problem that way. So the log base 5 of 15 is right here. Actually, I realized what I did, and I think I might have done that problem a little bit differently. I first noticed that 15 is 3 times 5, so I broke that up as a piece because what's nice here is the log base 5 of 5 is 1. And then because this has the wrong base, I chose to change it to a natural log. Notice the 3 was on top and the 5 is on the bottom, so there's B over C. Now, as it turns out, we could have done it a little bit differently. We could have done the natural log of 15 over the natural log of 5. We could have just jumped right to that change of base formula, which is the natural log of 3 plus the natural log of 5. And then if you look back, the natural log of 3, of course, is B. The natural log of 5 is C over C. And if you look at this carefully, this is B over C, and then C over C is 1. And that actually does work. Okay, so that's, let's see how much more we have to go. Yeah, let's do maybe 1 or 2 more before we move it on. So if you have a problem that is a log question, the smart play is to try to get rid of those. So again, applying that definition of logarithm that I wrote down right here, that the log base A of B is C, can rewrite that base to the exponent power. So x is my base, and I raise it to the 2 power is 5x plus 14. That's obviously a rigged little quadratic that's going to be easy to solve. I brought everything across, set it equal to 0 so I could factor it. And that leads me to these two answers of 7 and negative 2. Now the thing is 7 is a little bit of an issue. actually I should say the -2 is because you can never take the log of a negative. It's not allowed. So the base can't be negative, the log itself can't be negative, but something that's nice to look at is, let's see what happens. This is the log base 7 according to my answer right here. X is 7. 5 times 7 is 35, and 35 and 14 is 49, and the problem says the log base 7 of that has to be 2, and I think you can see right now that 7 to the 2 power is, in fact, 49, so that problem actually worked out pretty darn well. All right, one more, and then let's go ahead and kill this video. Now, let's make sure I have the right problem up there. I think that's number 12 is next. It is. Okay, we'll do one of these kind of crazy hard problems. Actually, this isn't too bad. I noticed that in number 12, I think I did a little bit of work here. The 16 and the 64 are both very definitively values that have to do with the number 4. The square root of 16 is exactly 4. 64 is 4 cubed. So that makes 4 to the 3rd, and then a 6th root, that's 4 to the 3 6. And so that's where these numbers came from. You can see I used a little whiteout. I think I wrote it in a different way and decided I wanted to change. So what I have there is 4 raised to that original exponent. And right here, I've got 4 to the 3 6. And so as soon as the bases are the same, then all I have to do is compare the exponent. So 3 minus x is this exponent, 1/2 or 3/6. I did some quick arithmetic. I did a distributive property. Actually, I think what I chose to do is I multiplied both sides by 2 to make life a little bit easier. And I pretty quickly come out to a nice answer of 3/5. And not to beat this point too much, but keep in mind, we just said that x is 5/3, right? So that means if I took 5/3 and stored it as a, and you don't have to store, I just like doing it that way, 4 raised to the 3 minus a power is some weird, terrible looking number. But then if we look at the other side and we took 4 to this 3/6 power, and then I'm going to hit enter, and I'm going to raise that to the a plus 1 power, because it was the x plus 1 power, I'm hoping I'm going to get 6.3496. So that tells me that in that whole scope, I actually did okay. Again, I love making students feel a little bit confident that the results that they're doing make sense. So we'll be back for one more video, and we'll be done with the entire review.